is A.Dimitri, a phet fellow and lab exchange teacher ambassador. In this video, I will describe how you can integrate OpenBoard with the phet simulation so that you can create an effective active lesson. OpenBoard is an open source interactive teaching tool that allows teachers to explain scientific concepts clearly and also work out mathematical problems. So OpenBoard can be downloaded from the website openboard.ch. So it is available for Mac OS, Windows, as well as Linux variants. So you can download and install. So we can embed phet simulations. So we go to this function, embed, and we can copy then right click and copy the code. Then we can proceed to the OpenBoard. So OpenBoard is already installed in this machine. So open. Okay, so we have the board. It's like an interactive board. So we've got the eraser. We also have the writing pen. Then we've got the marker, the highlighter, and also line drawing tool. Another advantage of using OpenBoard is that you can record your lessons. So by clicking the podcast function, and it will open this one, then you can click this button, the red button, and it will start screen recording. So in this, I'm going to demonstrate an experiment of determining the resistance of an electrical appliance. So I've got already prepared the instructions. So I'm going to the documents, then import the instructions. Then after importing the PDF document, we can click open in board. So these are the instructions for the practical. So to determine the electrical resistance of an appliance by measuring current and potential difference. Then I have got this circuit diagram and the table for recording. Then after recording, we are supposed to draw a graph by plotting voltage against currents. Then draw a line of best fit, then calculate the gradient. And the gradient is equal to the resistance. So on the first page, I need the table. So we also have the other two, which allows you to take a screenshot within the OpenBoard. So you can add to the current page, add to the new page, or add to the library. So I want to add it to the new page. All right, so it will appear like this. All right, so in this page I'm going to insert that code we have copied in the previous. So in this we are going to paste the code, then click embed. So we now have, so this allows us to perform the practical as well as recording. So I'm going to let me bring in the, so we can go to the previous. So since I forgot to copy this one, I can do a screenshot or add it to the library. Then from the library, I go to the pictures, then I can, that captured, so I can drag and drop it into the whiteboard. So from the circuit diagram, I've got, all right, okay, so you have to go to this button, which is written interact with items, so that there's no movement. I don't need to show the electrons. All right, so this is my cell. Then I want to add wires. Then I want to add I will add the bulb. And I need to add a switch. Connecting wire. Then I want to add the voltmeter. It is connected in. So the voltmeter is connected in parallel. And I want to connect the all right, I need to connect the ammeter. I think my diagram is now okay. It's now okay. All right. So I'm starting. I want to start with a voltage of 3. All right. So now the voltage is 3. But the current is 0.3. Next, I'm going to change the voltage to 6. Alright, get back to the pen, then the voltage is 6, then the current is 0.6. Get back to interact, then power off. Close the circuit. Voltage is 9. Current is 0.9. Alright, so after gathering the data, we can also capture part of the screen. So I need to use the results in the next page so that I can draw the graph. So editor, saving the results, we now want to draw the graph. So we need the results. So these are the results. Then we need to add the graph paper. So the graph paper, we use the part which is written paper. So we drag it. Then there are different types of the paper. So but the graph paper is on this one, which is written millimeter. Then you click the tick so that you can insert. Then you can remove. So from the graph paper, the scale I'm going to use. So I need to sign. So voltage on the y-axis. So let's say this one is 0. Let's say this one is 0. So for example, this 1, 2, 3, 4, 5, 6, 7, 8. Okay, this one, let's call it 9. Alright, then on the x-axis I can put on the x-axis I want to use a scale of let's say 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that one is okay. Alright, so this one's 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9. then 1 comma 0. So on the y-axis it's voltage, on the x-axis is current per amps. So at 3 volts we have alright, so at 3 volts we have 0 comma 3. So I want to add. Then at 6 volts we have 0 comma 6. Then at 9 volts now the next thing we have to draw a line of best fit. So we have got a ruler, so we drag it into the board. Then we can, using this curly R, we can, so this ruler can be stretched. It can be stretched. Okay, so something like this. Then you can draw alright, so this is our graph. Then from the graph you can find the change in y. So you can find the change in y. So you can find the change in y and the change in, so for example this point, so like change in y, so change in y, then change in x. Then from that the formula can say resistance is equals to change in y divided by change in x. Okay, so after doing this, it's possible that you can also export your document as PDF by going to documents, then you can click export. So export to PDF. Okay, so guys, I think